So today we're going to talk about 2011 question 3. It is a calculator problem on the AP, I believe, but we're going to do it with no calculator today. And we're going to go through the problem and then we'll score it and see how we do. 9 points possible. This is an easier problem once we get a little well practiced. We hope for 8 or 9 is what we want. All right, so let R be the region between 8x cubed and sine pi x. So sine pi x is the bottom curve. Sine pi x, I was saying, is the bottom curve, or the top curve, and 8x cubed is the bottom curve. So I might do that. I might put f of x here on this one and g of x up here. And our interval is 0. We have half here on the x-axis. We have 1 on the y. So write an equation for the tangent line of f at half. Okay, we got to catch that it is not the horizontal line, okay? So I want to find f prime of x. All right, and I want to find the slope at half. So I'm going to find the slope, evaluate the derivative at half. Yeah, we're doing the problem. All right, so there we go. The slope is 6. Now we see from the board, from the graph, the point is half comma 1. So if it wants a line tangent, you have the slope of 6, you have the point half comma 1. I would simply do now slope of the equation of the line, which is y equals, not y minus 1 equals 6 times x minus half. And if I was worried about solving for y, maybe I'd move this over. And that would be my equation. And I would do it like this. And that's what's on the AP. Yep, so this answer is worth a point that I just underlined. And f prime of half, that you tried to do this, is worth a point. Okay? Yes. So again, 2 points. Half for the f prime of half, or 1 for half, f prime of a half, and another point for the line at the bottom. We'll group that. That is the answer to letter A. Stick that up out of the way. We'll go to a different pen color. Find the area of R. All right. Area between the curves is just the integral of the function from A to B. In this case, it'll be g of x minus f of x, right? Top curve minus the bottom curve. Now, the integral of this without a calculator is a little bit of a challenge. Yes? Yep. So I do the initial line. You don't have to. You could start with equals 0 to a half in the first function. I would write sine of pi over x minus 8x cubed dx. Now, I'll finish and I'll answer the question. Let me finish first. All right. Everybody, if you see it, you don't have to do it. But I'm going to do a u substitution here. All right, of u equals pi x. And do we see that du is pi dx? And if I do this substitution, just so we can see it in case we remember I get sine u. And if I'm going to replace the dx is going to come over. I'm going to do this. I'm going to do 8x cubed dx. And we know the dx is here too if I want to put this in, right? You guys see I can solve for dx if dx equals du divided by pi? And this is, some teachers teach it this way. They say, hey, you don't have to think about it. Solve for dx, right? I always multiply them. So I'm going to put du over pi here. So now I got some integrals. I bring out the 1 over pi. And we know the antiderivative of, negative cosine u is positive sine u. All right? Over here, and that's going to be evaluated. All right? And I'm going to just say a to b. And I'll tell you why. Because I can't put in 0 to half into u, right? I'm going to have to change the u back. And over here, I'm going to get 8x to the 4th over 4, 0 to half. All right? So I get 1 over pi, negative 1 over pi cosine. Instead of u, I put in pi x. Now I'll say that's from 0 to half. minus 2x to the fourth from 0 to half. All right, I got some math now. Do you guys agree? And this is one of those times it works out pretty well. I'm going to go down to, I better go to 75%. So here we go. I get negative 1 over pi times cosine of pi over 2 minus cosine of 0. Okay? Minus, over here I get 2 half to the fourth minus 0. All right, so then goes, guys, cosine of 90, 0. Cosine of 0, 1 for my unit circle. So I get negative 1 times negative 1 over pi. So I get 1 over pi minus 2 times 1/16, 1/8. The answer is 1 pi minus 1/8. There is a lot of... No, oh, I see if you did. I'm not going to find a common denominator. This is where I would stop.
Well, I did it all at once.
Okay. Didn't matter. Yep, they'll do it. Because back up here, the integral of sine is negative cosine, right? Because derivative of cosine is negative sine. Yeah, and I brought the minus out then to here. See it? Okay. Everybody, if I go back to full screen, this is a long problem. All right? Your points are 4 points possible. The integrant, all right, right up here, if I get rid of this blue stuff I put in here, this red integrant right here is a point. Okay? That you went g of x minus f of x. The antiderivative right here, not the limits of integration, but that you did the right antiderivative is worth 2 points. And finally, the answer in some form, okay, is worth a point. Okay? So there's 4 points on this second problem, which means if you think about it, there were 2 on the first, 4 on the second. That leaves 3 points on the letter C option. So we'll group this. This is the answer to B. Your class is already done up there, Sam?
Yeah.
All right, I'm going to finish this, and I'll put it out on video. All right? All right, so there's B, and I'll erase this B. All right. Yes. All right, letter C. Write but do not evaluate integral expression for the volume of the solid generated when R is rotated about the line y equals 1. Okay, we're going to go around y equals 1. We got to do this. Y equals, you don't have to, but you want to do this. You want to do a of x dx, in my opinion. Because we're going about the x-axis, I don't want to solve these for y. All right? So, one thing you can do a lot of times on the AP to make yourself, we take our butter knife, right? And we cut right here. And I think you see that this is a washer. Okay? All right? So I think we see that this is a washer. And the inside radius goes to g of x. You guys agree? See, right? It goes to g of x. The outside radius goes to f of x. Again, I see it goes 0 to half. And it's pi RO squared minus pi RI squared dx. Because it's a washer. All right? And again, I'll pull the pi out. And now I just have to figure out the outside radius and the inside radius. All right? And if I start, again, if you're not seeing this, I like to work through the thought process of this. Maybe we'll call it this, we'll do it this way this time. All right? I'm gonna draw the radius as I want. I'm gonna start with the outside radius. There's RO. Does everybody agree that this height is f of x? All right, and RO plus f of x equals 1. So if I solve for RO, we should see that this is 1 minus f of x. Okay? Likewise, it's going to be 1 minus g of x for the inside radius. Now it said set up but do not evaluate, right? You guys catch that? So all we have to do to finish, all right, is put in f of x and g of x. So our last step here is this. 1 minus f of x is 8x cubed minus g of x is sine pi over x. They're both squared. Don't forget the squares. dx. Everybody, this is worth 3 points. Limit 0 to half and pi are worth a point. You have that, give yourself a point. That's worth a point. The rest of this is worth 2. And you have to have it completely right.
So how do you know that x inside?
Okay. I'm going to go back up to the top picture and show you, all right?
Because that's
Yeah, you know g of x to the inside because this is the top. You agree that's the top curve?
okay.
We're spinning about y equals 1.